So in the previous video, we have started with 1-1 condition. I'll repeat it again. In the general definition, I told you that different elements should have the different image. So here we will say two elements A and B. Fa and Fb are their images. I say if this function is to be 1-1, then first condition I told that if A and B are not equal, means they are two different elements, then these two should be different. If I say they are not equal, then this should not be equal. If this condition comes that A is not equal to B, then Fa is also not coming equal to Fb, we'll say yes, function is 1-1. Or you do one thing, you go the other way. I say Fa is equal to Fb. Two elements are there, A and B, and their images are coming same. If their images are coming same, and these elements are also coming same in that case, A is equal to B, means if two elements have the same image and those elements are also coming same, Fa is equal to Fb, two elements have the same image, and in that case what you will find, A and B are also coming same, they are not different, means we will say same element have the same image, then we will say yes, function is said to be 1. So these are the two conditions we should prove. It will be 1-1. If it is not 1-1, then it will be many 1. In many 1, what we will say, if A is not equal to B, then I'll show Fa is equal to Fb. A is not equal to B means different element but have the same image. Fa is coming equal to Fb. This is many 1. Or what you should say, if Fa is equal to Fb, implies A is not equal to B. Elements image are same but these elements are different, then we will say yes, it will be many 1, it will be also many 1. So this will be the case for 1-1, or this will be the case of many 1. Whenever function is not 1-1, it will be many 1. Whenever it is many 1, it is not 1. So out of 2, 1 will be there. Any function, either it will be 1-1 or it will be many 1. That you should keep in mind. So whenever I want to prove that it's 1-1 function, I should take A and B two element. I decide that whether they are equal or not. If by the way they are not equal, A is not equal to B, then I have to show that Fa and Fb are not equal. Or I take two images, they are equal, and I show that their elements are also same, then we will say yes, it will be 1-1. So if you take images are same, then I have to show A is equal to B for 1-1. If A and B are not equal, then I should say Fa is not equal to Fb. Don't do this, please. This definition you can't use. That if A is equal to B implies Fa is equal to Fb. This is the obvious condition. This you can't say for 1-1. ये 1-1 की condition नहीं है. This is not 1-1 case. This is not the definition for 1-1. Why? Because if you are saying A and B already equal, how their images can be different? Automatically it has to be, because otherwise if A and B are equal, that means they are same element. How the two elements can be different? This you can't have. If you have this, then it cannot be a function, because different element, same element, if you have A and B, you are saying same. I'm saying these two are equal. If these two are equal, what does it mean? If they are equal means they should have only one image, means Fa has to be Fb, because this is the condition for 1-1 function. Otherwise it cannot be possible. So you will not be using this. So don't reverse it. Either say A is not equal to B, then Fa is not equal to Fb, or Fa is equal to Fb implies A is equal to B. So any one definition you will be using for 1-1. Otherwise, if it is not 1-1, then it will be many. That way we go. Second case is onto and into function. Onto and into functions. Second case is onto function or into function. Now what is the meaning of onto function and what is into function? Here in this case, if I take set A, here we take set B. 1, 2, 3, 4 here, 2, 5, 7 here. By the way, this is giving image this will be giving image this will be giving image this will be giving image this. Second case, I'll take 1, 2, 3, 4, 2, 5, 7, 9. This is function f2, a and b. This is function f1, a to b. Third function also I'm taking. First check whether this is a function or not. We'll say yes, it is a function because each and every element has the image and that image is coming unique. This is again one function. This is a function again because each and every element has image this side and that will be unique. Here also we will find all the elements are having a unique image this side. First thing I'll ask, which one is 1, 1, which one is many 1? Here in this case, what you will find, different element have the same image. So it will be many 1 function. In this case, each and every element has a different image, so it will be 1, 1 function. Here in this case, different element but have the same image, so it will be many 1 function. So we have decided 1, 1 is there, which one is many 1, we know it. Now we want which one is onto and which one is into. Whenever we think about onto or into, we are considering the second set. In second set, here whenever it is a function, we have already done that each and every element should have the image this side. I have not bothered about any element here having its image this side. Now keep in mind one thing. 1 will have the image 2. Then 2 will have its pre-image 1. 2 will have pre-image 2 also. So pre-image can be more than 1. Here we have 5 as pre-image 3 and 4. 7 will not have the pre-image at all. Here 2 will have pre-image 1. 1 will have image 2. 5 will have pre-image 2. 2 will have pre-image 5. 7 will have pre-image 3. 3 will have pre-image 7. 4 will have image 9. 9 will have pre-image 4. Here we will say 1, 2, 3, 4 all will have image 2 and 2 will have pre-images 1, 2, 3, 4. Right? Now, we are going to consider in this case the second set. Till now we are just bother about first set and their elements. Now we are coming on second set. In second set, what we are going to check? We are going to check that each and every element in the second set has its pre-image or not. In this case, what you will find, one element is without pre-image. In this case, all the element has their pre-image, maybe 1 or 2 or 3. We are not bothered about it. It should have the pre-image. Yes, it is. Here what you will find, it has again all element, this single element is there, all have the pre-image. So in this case, whenever you say these three cases, if I discuss, one element is without pre-image here. In this case, if one element is without pre-image, we will say codomain is not equal to range. If I'll say codomain, 2, 5, 7 is the codomain, but range is 2 and 5. In this case, what I should say, codomain is equal to range. 2, 5, 7, 9 is the codomain and that is the range. Here in this case, again we should say codomain equal to range. Now, whenever function is onto, what I should have, simple in words, I should say each and every element in set B should have its pre-image. Onto function, whenever I say every element of codomain must have its pre-image. If each and every element has its pre-image, we will say it will be onto function. Or we should say, another way we can say, domain comes out to be, codomain equal to range. If any one of the conditions satisfy, or we'll say this and this one and the same thing. Here what it says, each and every element in the set B should have its pre-image. In this case, it is not there, or in that case, we'll say codomain is not equal to range. In this case, what you will find, each and every element has its pre-image, and that's why we'll say codomain is equal to range. Here in this case, each and every element has its pre-image? Yes. So codomain is equal to range. So this function come out to be onto, this function come out to be onto, and this function come out to be. So here what you will find, this function is many one into, this function is one onto, this function is many one onto. So function is either one or many one and into or onto. So that means any function. Now the condition or onto I told you. Onto condition means each and every element in the codomain should have its pre-image, or I should say codomain equal to range. But if you find codomain and range are not equal, we will say it will be into function. So onto means codomain is equal to range, or we will say each and every element of set B should have its pre-image. In this case, each and every element has its pre-image, so it will be onto. Here, each and every element does not have its pre-image, it will be into. Here, each and every element has its pre-image, yes, we'll say it will be onto. So into, onto, into. Codomain is equal to range, and we will say every element in the set B should have its pre-image. So this way we will say the function is onto. Now one more thing we should know, that whenever they ask the question, they will ask what kind of function it is. So whenever you think about kind of function, the two part more will be there now. This is 1 on 2, and here it will come out to be on 2 or in. And whatever function given, either it will be 1 on 2 or it will be 1 in, or it will be it's many one 1 on 2, 1 into, many one on 2, or it will be many one. 1 function also called as injective function. 1 function also called as injective function. Onto function we name as surjective function. These are the two special names are given to you. 1 function, whenever I say, it will be injective function. Whenever onto function, we call that as a surjective function. And whenever function is 1 as well onto, that means this case. 1 also and onto also, then it is called bijection. This is an important one. So any function which will satisfy 1 onto condition, we call that as a bijection. If only 1 injective, many one will remain many one. Onto whenever we say surjection, and into when you say, it will be no name for it, keep it as it is. But whenever 1 onto, it will be called as bijection. So 4 kind of function now we have. One is 1 onto, 1 into, many one onto, and it is many one. So 4 kind of functions we have. 1 onto, 1 into, many one onto, many one into. So this way we will be having 4 functions. We should remember 1 onto, many one into, 1 into, many one onto. So 4 functions are there that you should keep in mind. And now in the questions they will be asking you prove that that the function is 1 onto is there, or bijection is there, or no. That way they can ask. Now whenever we think about onto, I told you one thing here. One more thing I'll tell here. If this is the set A, this is the set B, x is here, then this is fx, which we tell as y. This is the function we have. If function is onto, what I told you, each and every element of this, that is B, should have its pre-image. So whenever we want to show onto function, what I should say, for all y belongs to B, there exist. This is the symbol for there exist. X belongs to. If you prove this, Means every y there is x, we will say yes, function is onto, otherwise the function is into. Now how we'll start doing questions on it, that I'll take. First question, write down please. Fx is one function is given here. Function is f given from natural number to natural number, and fx is 2x. My question is, check whether this function is 1 1 onto or no, or it is a bijection. Whenever we start 1 1 function, we should start with let a and b belongs to two elements we are taking from the domain, n domain. Such that fa is equal to fb. I told this definition. When 1 1 is there, I just take fa is equal to fb and I'll show a is equal to b. Or I take a is not equal to b, then fa is not equal to fb. But we'll take this case. Fa is equal to fb. What is fa? It's come out to be 2a. Then it is coming to b. What does it mean? This implies a is equal to b. Therefore, what I should say, fa is equal to fb implies a is equal to b. So f is 1 1. That we have decided. Then we go for onto function. In onto function, what we do here? Let fx is equal to 2x will be taken as y. And what I have to show, every y there will must be x. So here fx is 2x is y. What I should have here 2x will be y, right? So x comes out to be y by 2. Now if you check, x is y by 2. Y is an integer, yes, natural number. Its half is another natural number? No. That means what you will find? You will say is not natural number in every case. Or what you can say, or if y is odd number we take, we don't have x. Simple example I'll take. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Just check here. When you take 1, image is 1. When you take 2, image is what? Sorry, 1 when you have, image is 2. 2 will have image 4. 3 will have image 6. 4 will have image 8. So what you will find, each and every element has the single image. A is equal to B. Fa is equal to FB. We have shown that A is equal to B. Right? So if images are same, elements are same. But in this case, what you will find here in the second case, every element y which you take, y is coming from here. What you will find, every y will not have x here. Because 2x is y, x is y by 2. What that indicate? Is not a natural number in every case. Or we'll say if y is odd number, x does not exist. So we don't have x. So what you should say? For all y belongs to n codomain, there does not exist x, which is y by 2, as natural number. Therefore, what I say, f is into. So what I should say, function is not 1 1, 1 1, but not into. Next class will take more.